All right, so let's get started with procedure part A of this experiment. So as you will recall from the manual, the goal here is to measure the period of a pendulum as a function of its length for small angles where we expect that the release angle doesn't matter. So we've got our pendulum rigged up over here. Right now I have, I lengthened the string. This is about as long as it's going to get. It's just eyeballing it about a meter. We'll actually measure it carefully in a little bit. I taped a paper protractor to the top of the stand over here. And that's just to help us release the pendulum from a roughly consistent angle. We'll do a small angle, something like 10 degrees or so, where the small angle approximation should be pretty good. Okay, so we'll get started here in a second. Okay, so today it's Tuesday, March 17th. We're in the whole new world.
St. Patrick's Day.
Ah, all right.
Happy St. Patrick's Day, everybody.
Okay. there we go. So just one note of difference. So looking at your lab manual here. So we gave you some tables to fill in with your data. I'm going to be taking notes in my experimental notebook here. So I've written in today's date, the 17th. And this is pendulum part A, so period versus length. Now the one difference between what the manual says and what we're going to do is because I'm using this Rigel function generator here, compared to the BK precision ones you've been using, the frequency here is way, way, way more stable. As we've talked about before, right, when we think about uncertainties in experimental measurements, we sort of want to think about what things contribute small uncertainties and large uncertainties. Using this function generator, the frequency is so much more stable that, yes, I could go and look up the manual on this and figure out exactly what the manufacturer rates the accuracy and stability of the frequency is, but it's going to be such a small effect relative to all the other measurement uncertainties that even though the manual asks you to record an uncertainty in the clock frequency, we're just going to assume that the clock frequency has zero uncertainty, which nicely enough makes your uncertainty analysis math a little bit simpler. All right, so looking down here, I have this indeed set to a frequency of 1 kilohertz. Monitoring this on the oscilloscope, we're still seeing the clock at 1 millisecond period, so 1 millisecond per division, and the clock taking up 1 box. Okay. So let's turn on our timer here. Again, so let me clear this, and we've got this period set, we've got switch S1 set low. All right, so I want to get a little bit of a sense of the uncertainty in the period. So when I do this particular length, I'm going to measure the period a couple of times. And then by comparing the counts we get, we'll get a sense of the uncertainty. And frankly, that's going to be way better of an estimate of the uncertainty in the measurement than fiddling with the clock. Okay, so length number 1. So I have this length now. Let me maybe start by measuring the length. And it may be hard to get the whole thing in view here, but so if you at least take my word for it, you can sort of see how the knot at where the pendulum is swinging from is sort of right up against the bottom edge of this crossbar here. So that's really the pivot point, right, sort of where my finger is right now. We're also going to want to look at the center of mass of the pendulum bob, which is this roughly spherical bob. I'm going to take it to be right at the center. So I'm going to try to go and measure that as best as I can. So I'm going to try to butt the edge here right up against the meter stick right up against the pivot point. I'm going to go and try to do this without my hands wobbling too much. I'm going to look at the center of the bob and try not to have too much parallax. So I'm going to just ease myself down here. And yes, this is a little awkward, but you'd be sort of contorting yourself. Here is what if you were doing this. This is where a partner would be really awesome, but that's okay. Okay, so looking at where the center here is, I would say that the length of my pendulum is about 95.0 centimeters, plus or minus a couple of millimeters. So I'm going to go write that down. So I'll write this down. This length down as 95.0 centimeters. And again, given that there's a little bit of uncertainty in me holding this up and keeping everything straight and reading without parallax, I'm going to write down an uncertainty of, let's just give it a conservative estimate, 0.4 centimeters. So that's 95.0 plus or minus 0.4 centimeters for our length. All right, so let's now get this thing measuring. So our clock is set. What I'm going to do is I'm going to try to pull this back to about 10 degrees. Or let's try to release this straight, and it may or may not. All right, so that's go up there. So I'm going to let it swing for a period or two to get stable, and then we're going to time it. So, ready, and now. Okay. So that's one measurement. So let's giving me for this swing, we have, I'm reading my timer, that's 7 C7 in hex, and just grabbing my codes here for these. So that is, so that's 7, so our reading is 7, A is in alpha, 7 in hex. All right, so let's just do that again, just to convince ourselves that that our results are consistent. I'll clear my counter now. Now it's 0, 0, 0. My switch is back at, my switch S1 is back low, and just in case you can't quite see what I'm doing, I'm setting this high, I'm letting the pendulum swing through one complete period, and then I'm switching this back low to stop the counting. Okay, so just to remind us, right, so I've cleared the counter, I've got S1 at low here, and just in case it's not clear what's happening, what I'm doing is I'm sliding the switch high, letting so that counting starts, letting the pendulum swing through one complete cycle, and then sliding this low to stop counting. Let's just do the measurement again. I'm going to restart the pendulum since it's been swinging for a while now. So, whoa! Okay, so this is probably not great lab safety. You should, in general, one should like stand on ladders rather than chairs, but I'm going to don't imitate, don't do as I do here. So that's about a 10-degree angle. I'm going to try to release that straight. And that's not quite into the window. Let me just do that one more time. Just release that. Up and now it's bouncing, so hitting the photo gate. Let's try that again. I'll try to release it straight on. Alright, let's let this settle in. And we'll do now. Okay, this time we are reading a hex reading of 7, A as in alpha, 9 hex, so 7A9 hex. Let's do this yet again. So I'll get 3 or 4 measurements to give us a sense of the uncertainty here. Okay, once again, we'll start this about 10 degrees and release this straight. Okay, I'm going to clear my timer here. Get ready. Okay, and this time we've measured a period of 7. A as in alpha, A as in alpha, hex. Let's just do this maybe one more time. We're getting maybe a little bit of a sense of the uncertainty in the measurement. I'll clear this here. And let's do this one more time. Okay, so it's about, what is, all right. And we'll go and here. Okay. And this time we've measured once again 7 alpha A and A hex. So the same measurement as the last time. Okay, so I'll let you think about sort of what would be a reasonable uncertainty here based on these 4 measurements. But I think we've got a decent sense of what's going on with the system now. So what I'm going to go ahead and do next is I'm going to shorten our pendulum a little bit. So we're going to keep recording here. I'm going to go through doing that sort of live on video once so that you can be convinced that I'm not trying to pull the wool over your eyes, but then when we do other lengths, I'll probably just skip that. Okay, so I've got a pair of scissors here. I'm going to go and I'm going to stop this. I'm going to clear and turn this timer off. Okay, so ropes and knots were never really my forte, but I'm just gonna tie a super duper knot here. So that actually is loose enough that I'm just gonna need scissors. So I'm gonna now pull this guy to be shorter. You can see that's a bit shorter than we had it before. I'm gonna tie this off here. Probably most of you are better with knots than I am. If you were ever a scout, or a boy or a girl scout, maybe you did a lot of practice with knots back in the day. There was a point in college when I actually had to memorize for something, for an organization I was in. I had to memorize a whole bunch of different knots, but I have to admit I've probably forgotten all of that. So yeah, so I don't think I could really tie a figure 8 on a bite to save my life now if I had to. Okay, so we've got this knot here, and you can see that the pendulum is in fact shorter than where we had it before. So I'm going to measure the length first, and then I'm going to raise the photo gate to the level where it will measure. Let's do a length measurement. Once again, butt this up against the corner and try to eyeball. Oh yeah. Okay. Again, trying to not have too much parallax here. Let's And keep this straight. And oh, okay, that's there. Okay, whoops. And I would say that this is right about so 79 point. It's about. Okay, so I'm going to round that to just about 80. And let me grab my notebook, which I put down. Where did I put my notebook?
Oh.
It's over here.
Oh.
I'm gonna. So my second lens number 2. I'm gonna say that that's 80.0 centimeters, plus or minus 0.4 centimeters once again, and I'll sort of give you a sheet with these measurements later on. All right, so we've got our lens. I now need to rig up my photogate to get this to work. I'm gonna raise this one first, and like that. And I'm going to raise this side here as well. And so I need to make sure so I'm going to turn this on. I've got to make sure that that I've got light shining into my photo transistor. Let's lower. All right, so we can see right now that with light shining in, my LED indicator is low, and if this comes in here and light is blocked, that LED indicator is high. So, whoops. Hopefully, as we see it, right, and we see that that LED one is going red, and the pendulum swings roughly through the bottom. So I think we've got this photogate set up correctly. Oh, and I'm noticing that my string is bouncing against the free end of the string. I'm just going to tie that off because we don't want that to be. That's not part of our model. So I'm going to just tie this guy off, wrap them around here so it doesn't interfere, and that should more or less give it a few more twists there. More or less. Okay. All right, so we're just going to go and repeat the same experiment. My counter is cleared. My switch S1 is low. I'm going to get these scissors out of the way. All right, we're going to release this from about 10 degrees. Again, put that stuff there. And I'm going to pull this back. Let that swing settle down, and we'll get ready to, and now. Okay, and this time, our period, so our period here is now 7, 0, 6, X. Let's do it again. Degrees. Use this here. All right, let it clear. I'm gonna clear my counter, and I'm gonna now. All right, we got exactly the same thing. We have 7, 0, 6 hex once again. Let's do one or two more measurements just to be on the safe side here. I'll clear this, climb up there again, and okay, that's about 10 degrees, and I'm gonna release it. That looks like I'm gonna do that again. It's about to hit the photo gate, so let's just try that again. About 10 degrees. Okay, all right, and now let us get ready to count. All right. And we're bang on same result again. And this time we have, once again, 706 hex. All right. Yeah, okay, so that's 3 measurements, and they all gave me 706 hex. So we're going to go now and shorten the pendulum again, and then continue taking data. All right, so you can see that I've shortened the pendulum again. Let's go and measure its length, and then we'll do a bunch of period measurements. So, okay, this is always awkward, but I'm going to stick this meter stick up here and try to eyeball this. Okay, and that's like straight. Okay, this is now about 60, I would say that's about, right about 66.9. Lens number 3. 66.9 plus or minus 0.4 centimeters. All right, let's go and get some period measurements. And you can, so we've got, taking some notes here. So we've got a steel ball bearing. Okay. All right, let us go, and we've cleared our counter. Our clock is still at 1 kilohertz. I haven't changed that. All right, let us now. Oh, let me put this down so that I don't whack myself. Okay, let's try to release this from about 10 degrees. Like that. And there we go. All right, so let's settle down, and we go now. Okay, and this is now reading T equals 669 hex. 669 hex. Let's do it again. Oh, and let's clear our counter, so that's this button to do that. Alright, it's about 10 degrees here. And let it go. Alright, and let's get ready. And now. And now. Alright. This time, I have 6, and I need to look at my hex code. That's 6, 6, C as in Charlie. Hex. Let's check that again. The symbol is a U, so it's, yes, it is in fact 6 Charlie. All right, let's do this one more time. Clear the counter. Set this up here. Start back from about 10 degrees. Swinging. All right, and let's get ready to count. Okay, and we got exactly the same result. 6, 6, C as in Charlie, hex. Again, our clock is still at 1 kilohertz. All right, so we've got length number 4 set up. Now we've got, you can see that this is way shorter than when we started it. I'm going to go and measure the length one more time. I already checked that the photo gate is doing what we expect. This is a little easier now that this is shorter. Let's get that up top there. I'm going to try to measure it without parallax. Oops, everything out. Whoopsie daisy. All right. And it's looking straight on. And that's like 44.5. Okay. That's about, okay, the length number 4. This is about 44.5 plus or minus 0.4 centimeters. Okay, let's do our period measurements. Okay, clock is still at 1 kilohertz. I suppose I could turn it up since we're measuring shorter and shorter periods as we take the length of this down, but to make your lives simpler so that you only have to deal with one frequency for this part at least, I'm gonna just leave it at 1000 hertz. Okay, so let's do this. Okay, I'm gonna try to again eyeball with my protractor here. We're gonna get more precise later on. Right, and we've got our pendulum swinging. All right, and let's get ready to do a period measurement, and now. Okay, so that gave me a measurement of 534 hex. Repeat, 534 hex. Do it again. Clear here. Eyeball this as best as I can. Like that. Oh, okay. And swinging, settling in. Get ready. And now. Okay. This time we got a measurement of 539 hex. Okay. 539. I'll do that one more time. Clear. Wonder if I'm probably not doing a fabulous job of releasing this exactly the same way every time, but who knows. Just try to be okay, that looks good, and I'm going to release it. I might be sometimes letting the pendulum swing at a little bit of an angle. I wonder, even though I'm trying to minimize that. Excuse me. All right, let's, okay, get ready to measure. Okay, and this time we got a period of 536 hex. Repeat, 536 hex. All right, so we've got a little bit of a sense of the spread here. Let's shorten the pendulum to our shortest length. So we're going to aim for around 20-ish centimeters, and then we'll take our last run. All right, so we're here ready to do our final length. This is now, you can see, much, much shorter. Let's go and measure the length. So okay, I'm just going to hold this meter stick up here against the crossbar. Try to read this without parallax. And I would say that's like 26 point, let's call it 26.3 plus or minus 0.4 centimeters, so length number 5, 26.3 plus or minus 0.4 centimeters. Okay, I've checked out that my photo gate is working. You can kind of see I'm pretty much as far as I can stretch the cable here. In fact, I actually, when I first set this up, I had pulled the 22K resistor out, and I had to just move the timer to get enough of a cable run. All right, let's go. Let's give this a go. Clock is still 1,000 kilohertz. So 1,000 hertz or 1 kilohertz. And let's pull this aside for about 10 degrees. And it's swinging, and let's get ready to time. And now, okay. So this is our period. This is 3, and blank is F as in foxtrot, so that's 3F, and the other value is E as in echo. Repeat, that's 3 foxtrot echo hex. All right, let's do it again. to about 10 degrees. Right, and get ready to time. And now, okay, this time we have, once again, 3 foxtrot, and this is the, it's like the 5 missing the side, so this is 3 foxtrot delta, D is in 3, FD, 3 foxtrot delta X. Do one more measurement, clear our counter, pull this out, and to about 10 degrees, let that go, it's swinging, okay, and we'll get ready to time. Okay, and this time we have 400 hex, 400 hex. All right, so this completes procedure part A for our pendulum experiment. When we come back, we're gonna do procedure B, which involves measuring the period of the pendulum for different initial release angles. Thank you.